Okay, welcome back to the Astro Nerd channel as we focus here on astrophotography, specifically with the C-Star S50 and how to take the data there and edit it in PixInsight. Um, Currently in my astrophotography journey, the only equipment that I'm currently using is the C-Star S50 just because of time and because of the ease of use of the equipment itself. So here recently, this last week, I took a little bit over 1,600 10-second exposures of the Whirlpool Galaxy, and you can see the image that was created by stacking those 1,600 images over here to the left. This is the original master light fits file that was an output, and as you can see, when you image a single target over 1 to 2 nights and you get several hours of data between those 2 nights, you get something called field rotation here within the image, and that's just because with an alt azimuth um, mount, you get field rotation as the target moves throughout the night sky throughout that evening of imaging. And so with that, you get some challenges that occur with being able to image the target and being able to process that data. And that's what we're going to walk through tonight. So earlier this morning, I was able to take this original master light file that had been stacked from those 1,600 images and turn it into what you see on the right. And so I'm going to run through fairly quickly the beginning stages of the processing, because I'm going to show you something that it seems like we're having to do more and more with images coming from the C-Star, and that is using something called a false flat to deal with some of the background modelization that is happening within the image. And part of that primarily is because of this field rotation and how you can see that even though the C-Star dithers, there's still an issue with noise patterns in the image, and you can see that here. I've actually taken this image, cropped it, rotated it, and if you look pretty closely, what you'll see here is you'll see some pattern to the noise. It's not exactly natural or random. It if you look closely, it almost looks like it's in a circular pattern here around the image, and that's because I believe the field rotation. So what I did is I took the master light, I cropped it out with using the dynamic crop feature, and that's in my other video, and then I rotated the image. Then after you crop and rotate the original light frame, you have to go in and re-image solve that image. So once you do that, you'll be here with this image here, and we'll pick it up from there. So let me go ahead and pause this just for a moment so we can get ready to walk through the normal processing, and then I want to show you um, how to do the false flat to deal with this noise here. Sometimes this noise can be dealt with in one of two ways. Sometimes the noise is subtle enough that you can back down your background brightness. As you can see here, if you look at the R, G, and B values here, um, if those are a little brighter, you can sometimes darken that to where it's not noticeable in the final image. But if you notice here, we're already to kind of 15, 13, 14 on the readout, and that's already fairly dark. Um, and so to me, I don't like to have a totally pitch black background. As you can see over here on this final image, it's between 11 and 13. Um, and that's just because there's a lot of faint black details that get lost or get clipped if you try to go too dark in your background. And so in a situation like this, what we have to do is address this with something called a false flat. So that's what we'll do is we're kind of picking up the processing here with, you've already cropped, rotated, you've already done the spectrophotometric color calibration. You've already done kind of your basic setup with blur exterminator, noise exterminator, and you've already done a basic stretch to the image. And so that's kind of where we're picking this up at, is we've done that stretch to the image, and we're ready to kind of go into the more advanced areas of the processing. So that's kind of where we're picking up this work here tonight, because we're going to focus on creating this false flat, which is a fairly in-depth process. So that's what we're primarily focusing on here tonight, is what do you do when you have an image from the sea star and you've spent, several hours collecting data, which you think is going to be good data, and it is, but what happens when you have this subtle noise pattern where basically it's occurred because of field rotation? Because I've already done a dynamic background extraction of this, or I've used Graxpert, but this is still present. So how do we address that? Okay. So what we do is, I'm going to go ahead and minimize this, as it's not something we're really looking at the moment. That's kind of the finished image we're trying to get to. So let me just go ahead and hide that up there. And what we're going to do is show you this process. Let me just go ahead and make that size. Okay. The first step we need to do is, I'm going to go ahead and copy this a couple of times just to make sure we have a couple of copies to work with. We can go ahead and hide those for now. And this is the one we're going to use. The first step in making this false flat to deal with this modelization is we need to go to starexterminator and create a starless image. So let's do that. Okay, and hopefully you can hear me a little bit better now. I just noticed that my mic gain was down a little bit lower. All right, so we have the starless image, and we've removed our stars, so we're going to just hide that for now. And what we're going to do is, this is where the work starts. And notice we're doing this on a color starless image, not a black and white or luminance starless image. There is a couple of other tutorials out there on YouTube that deal with this from just the luminance layer perspective. But I found that the results are most consistent when you're doing it on a full color starless image. So yeah, and feel free to reference the other tutorials that are out there. They're probably going to be shorter than mine. Actually, there's one that has no talk at all in it. It's just about a 5 or 6 minute video that kind of goes through the steps, but they go fairly quickly. So you have to watch it quite a few times even to get the breakdown of it. I actually already have a cheat sheet that's been typed up on this. So I'm going to make this available in the comments below. So hopefully that will help you as you learn how to do this on your own. Okay, so we have our color starless image. The first step we're going to do is go to Script, and we're going to go to Utilities and go to AdvStarMask. If you don't have this utility, just do a Google search and go PixInsight utility, and then type out AdvStarMask, and you should be able to find the suite of tools. They're free. You should be able to install those and get that ready to go. So we create our StarMask here, and then immediately what we're going to do with that StarMask, that AdvStarMask, is we're going to do an auto stretch to it. Once we've done the auto stretch, we're going to open up our HistoGramTransformation tool. We're going to reset that. We're going to make sure that it is selected on this recent image by clicking that check mark. And then we're going to drag this little triangle from the screen transfer function down to here. And then we're going to drag the histogram triangle on top of our AdvStarMask. Notice how it automatically added that stretch to it. Then we're going to reset the stretch. Now this is permanently stretched for the star masking that we're about to do. So once that's done, we then open up a tool called the Binarize tool. So go to Process, go to Binarize. And here what we're doing is we're trying to find the lowest K value on this image. So to do that, you put your cursor over the image, over the AdvStarMask, and you left click, and it brings up this little box, and you're trying to find the faint edge of one of these faint star areas. So I think I'm good with that. We save that there. It kind of saves it automatically into the Binarize function box here. And then we're going to drag this triangle on top of this AdvStarMask. And what that does is it raises your RGB and K value up to this area. And then what we're going to do after we do that is we're going to hit Control+I on our keyboard. And that basically inverts the image of what we're dealing with. Once we've done that, we're going to type in DM for Defect Map and then click Save. So we've saved that image with the identifier of DM. Once we do that, we're going to go ahead and just hide that for now. And then we're going to load up the Defect Map tool, which is down here under All Processes once again. And then for this, we're going to make sure that CFA images is enabled because we're dealing with a color image. So make sure that box is checked. And then we're going to load up the DM map that we just created, this defect map. So we load that in there. Once we've done that, we drag the little triangle on top of our color starless image. And that's going to work through the three main channels of R, G, and B. Depending on the size of your image, this could take quite a while or it could go pretty fast. Here it's going fairly fast because technically I've already done this once before, so it's probably saved in memory. And this is a fairly small image. If you drizzle and have a larger resolution image, that could take substantially longer depending on the speed of your computer. It could take up to 20 or 30 minutes. So yeah, so just be prepared for that process to be a little bit longer than what you just saw here live on the video. Okay, so now that we have our defect map set, the next step is to come up here to process, and we're going to go to range selection. All these steps are in the process of dealing with this modelization of the background noise. You see this circular noise that's in our image? This is what we're hoping to deal with. And basically what we're doing is we're creating what they call a false flat. Technically, the C-star doesn't need flats typically, but you can really take this principle that you're learning here tonight and use it not only for patterned noise. You could also use it if some kind of dust mote were to somehow get into your system and you started to see these little donuts show up on your images. You can also deal with those donuts with this process that we're building here tonight. So once you have the range selection tool open, go ahead and hit the preview button here, this little circle, and it pops up a preview of the image. And then we start to drag this top slider here over until we get to the rough outline of our main part of the image that we're wanting to focus on and basically hide from the rest of the defect map. So we've kind of selected the Whirlpool Galaxy here, as we can tell. That's kind of the rough outline of it. Then we're going to come over here and smooth this to maybe about, I don't know, maybe about 10. And we'll come up here and do a little bit more selection here. We just want to start selecting that, and then we're going to go ahead and hit the square icon to apply this and create ourselves a range mask. And so once we've created the range mask, we're going to then darken the background of the remaining part of the range mask by opening up the HistoGramTransformation tool again. We'll reset that. We'll click the checkbox knowing that we're dealing with this. We'll open up the preview by clicking the circle, and then we're going to back down our black point to where we're hiding this background image area to really only focus on the galaxy itself there with the range mask. Once we are happy, we hit the blue square, apply that, and then we're going to rename this RM for range mask. Okay, now that that is done, we're going to go on to the next step, and that is to open up Pixel Math. So go to Process, go to Pixel Math, and here what we're going to do is we want to find the median base value of this background. So in order to do that, we're going to use a formula, med, and then we're going to use the name of this image, which for me, it's new_clone. So MED, open parentheses, the name of the image, and then close parentheses. We're going to create a new image entitled BG for background. And I think we're ready to go. We're going to drag our triangle on top of that. And as you can see, what it's done is it's given you kind of a basic median value of that background. And it's kind of an interesting color. You know, it's somewhat of a grayish reddish color because that represents the median overall average of the background that we're looking at. All right, so now that that is done, we are going to take the range mask that we created a couple of steps ago, and we're going to apply that on top of our color starless image that we're working on. And what this is doing is it's showing you where the mask is enabled and where it's not enabled. We're going to go ahead and click to not show the mask so that we can see this a little bit easier. And what we're going to do now is go back to our pixel math. We're going to reset this. And now what we're going to do is type in BG here in our pixel math equation expression. BG, it's referencing this image here that we just created. Go ahead and minimize that over here because we're going to put it on this image here. We've got our range mask enabled. We're hiding the range mask. And now I believe we have everything right. We're not going to create a new image here because we actually want to do the change to this image. So we're going to replace the target image here with what we're going to do. And what we're about to do is do this process 3 to 4 times. You'll see what I mean here as we do it. So I'm going to go ahead and drag the triangle on top once. I'm going to do it twice. Every time you can see how it's filling in more of the area where the galaxy would be sitting. We're going to do it 3 times. That's looking pretty close. I might do it once more. We can always go backward. Yeah, we'll go 4 times. Typically 4, maybe 3. Just really doing it to taste here. It's kind of one of those areas where you kind of eyeball it and see what looks the best. So basically what we've done is we've isolated everything that's kind of this patterned noise that we want to try to reduce or get rid of. So now that we've done that, we're going to minimize our pixel math tool. We'll be coming back to that here in just a moment. We're going to take off our mask, so remove mask. And now what we're going to do is open up another process called Multiscale Median Transform. And when you do that, you're going to come over here to layers, you're going to go down to 8, and then you're going to disable the first 5 layers by double clicking on each green check, left double clicking. So turn off the first 5 layers, and then everything else should be default. If you've played with the Multiscale Median Transform tool before, you might want to first reset it by clicking this reset button in the bottom right corner, then set your layers to 8, then turn off those 5 layers because everything else is default. So what we're going to do now is we want to blur this background some to get even a more subtle sample to withdraw or to take out of our background here. So what we're going to do here is drag once. You see how that blurred that background somewhat? And let's try it one more time just to see what it does. It really didn't change much. I think once is all that we need there. So I backed up 1 step here by going backward and undoing. And I think that's good. We're happy with that. And so once we've done this, we're going to now rename this image SynF, and that stands for synthetic flat. So now that we have that done, we're going to close our Multiscale Median Transform tool. And now we're going to open up Pixel Math one more time. And this is where the fun happens. Let's reset our tool. We're going to create a new image here called corrected. And we're going to rescale the result. And here's the expression, the equation we're going to put in. We're going to do $T, which stands for target, the target image, / and then the name of this image here, SYN, capital F. Make sure to click on the Rescale result box, or this is going to look all funky here in a second when we basically take this flat. So what we're about to do, basically what the pixel math is about to do, it's about to mathematically remove this what we've isolated as this background modelization in the original image. And what's cool about this is we can either apply this to the image that had both the galaxy and the stars, or we could apply this to just the starless image, which would be, where to go? I Thought we had another copy of this. Maybe we don't. That's okay. We can do it to this one. Not a problem. So let me show you how this works. And if you watch closely, you're going to see some magic occur. So we're going to drag our triangle on top of this image because it's our target. Okay. If you look closely, the modelization that was in our background is gone. Now, what happened here is our colors got all thrown off. And so the way to fix that in our final step is to go to Processes and go to Linear Fit. And then we're going to take the name of this image, new_clone1. And we're going to, because we want to fit the data back because we pulled out too much basically as far as the color information. And so we're going to drag our triangle back on top of this new image that was created. And as you can see, now we have both images linear fit. And if you compare between the two, you can see how that this one has that subtle circular noise around the image, and this one is pretty much flat. Did a pretty good job. So that's how you create a false flat and use it to really clean up the background of your image. And notice how it didn't mess with anything else in the image. It just focused on this subtle but yet distracting. Because again, let's see if there's a way to do this. I think we can do this real quick. Let's come over here to HistoGramTransformation. Go to Preview. Yeah. So see, that's the original. You can see this circular pattern here, and the only thing I can figure that this is it's noise that's not necessarily random. There is dithering that's going on in the C-Star S50, but because of field rotation, I think that this patternization gets introduced into the data collection. But if you compare it to this image, notice how that's gone. Notice how all that circular patternization is gone. Obviously, we're not going to stretch the image to that because that would not look good. But I just wanted you to see that if you were able to raise that up and see it, it is completely gone in that image. So that's going to be something that we'll have to deal with for a while. I'm hoping that some kind of firmware update would come out to help deal with this. One thing that I liked about the C-Star S50 back several weeks ago is that they had basically unlocked access to some experimental features where you could actually play with the dithering settings. And I'm really hoping that ZWO will allow more advanced users such as us to be able to use that. So yeah, I'm going to go ahead and end this video here because it's already at 23 minutes, but that's how you create a synthetic flat for any kind of image where you've got this modeling that's going on in your background. And it's basically, you've already done color correction, you've already done a background extraction, either through Graxpert or through the dynamic background extraction tool, and you're still dealing with this subtle patterned noise that you just can't get rid of. And you've even ran Noise Exterminator because this was an image that we've already run some basic noise cancellation out on as well, but still we have that patterned look. And so as you can see, we were able to basically exterminate that rather effectively. So yeah, if you have any questions, feel free to reach out in the comments. I'm going to leave the 16 or so steps down there so that you can walk through them as you watch the video. And hopefully this will help you as you continue to grow and learn how to use all the tools that PixInsight affords us here with astrophotography. Thanks again.